Every time we would have a lightning storm go through, you would kind of sit up in bed and wonder, what piece of gear do I have to go out and fix next? This is the master control area where we run 5 different video signals through, where we control the commercial insertion as well as all the video storage. So we have hard drives that control all the video signals going through our plant at this point in time. Well, we built a 365-foot self-supporting tower in a downtown area. With that, we had issues with high lightning in the Midwest.
For KPTM, when they approached us, they had a lightning problem hit their tower, and it came in and it damaged part of their studio equipment.
You're talking sometimes $30,000 or $40,000 pieces of equipment that would be blown up when we had a lightning strike.
The biggest impact that it has, though, for them is they're off the air. And when they go off the air, then their advertisers are upset. When we went out to the site, it was typical of many broadcast sites. They have very limited space, and they're landlocked, and so their options for ground systems was extremely limited. And the solution we came up for this client was to do a combination of deep-driven grounds. There's 2 deep-driven grounds at that site, with ring grounds and then bonding and grounding, and then the system is laid out to expand to ultimately cover the entire facility.
This is where the actual deep ground was driven and then connected into the ring around the tower base. This deep ground is between 100 and 110 feet into the ground. And as they were driving it, we actually have a chart of the resistance. As the resistance was going down, we were shooting for 3 ohms or less. The interesting part of the connector that's on it, it's a mechanical connector where we can actually test the ground rod. We can take the connector off of it and isolate the ground rod so we can go back and test how it's performing. So this is the interconnect point where the actual grounding cable is connected to the tower leg. The bolts are all interconnected into the rebar that's in the foundation. And then it's also tied in to our incoming electrical switch gear. It's important to tie it in so we have a common ground with the utility, and then that also becomes our electrical ground inside for all our broadcast equipment. A lot of the manufacturers only have specifications of electrical cord grounding, but we try to make sure all of our racks are still, again, tied into the electrical ground as well as the outside loop ground. What we have is a grounding bar that is the central tie point for all the electrical equipment, for the electrical service, out to the grounding ring that is tied to the deep ground. The most important piece that we found about grounding is that you're not going to stop lightning, and the best thing that we can do is create the shortest path to ground. It's Ohm's law. It's really been the ability to maybe sleep better at night, knowing that we are protected a lot better than we were before we had the deep ground.